Hello, okay, this lesson we are going to look at exponential expressions and equations. In this particular video itself, we will just focus on exponential expressions. Okay, what is exponential expression and what does the word exponential mean? Actually, this is nothing new. Exponents basically means power or the index. Okay, so basically everything that you have learned in the topic of indices in your E-math is applicable in this topic. However, here we will actually be looking at the more A-math style of questions which require simplifying expressions and then later on solving equations. Okay, so you can look through this review examples on page 1 of your term 3 book. This would be basically all the laws that you have learned, and these are examples to show how the laws can be applied. Okay, I'm not going to harp too much on this. I just want you to take a look at the rules to see what are some of the patterns that we can observe so that later on for the questions we will be able to apply them. Okay, specifically I want you to look at these rules. Okay, so this rules tells us that when we multiply a power x and a power y, you can add the powers. When you divide, you subtract the powers. This rule tells you that when you multiply a power x and b power x, is the same as just multiplying first and then raising to power x. And similarly, when you divide them, it's the same as dividing first and then raising to power x. So in these two set of rules, right, one of the things I want to highlight is how we can categorize these rules. Do you see that these first two rules can be applied as long as we are looking at the same base? So if the base is the same and we are talking about either a multiplication or division, we can apply the rules 1 and 2. For rules 4 and 5, do you see that actually the base is not the same, but the power is the same? So as long as the power is the same, and again the operation is either times or divide, that's when we apply the rules 4 and 5. This categorization will be helpful later on when we are doing the questions on simplification. Of course, the other rules are also important, which you can take note of, the ones you have learned in E-math. Okay, so now let us go on to see how the simplifying expressions would look like. So let's look at page 2. Example 1 is a question that you would be very familiar with. It's the kind of questions you would have done in E-math. So just to recap, how can we do questions like this? Now there is a bracket power here and the bracket power here, which means all the terms inside the bracket should be raised to power 2. So basically 1 power 2, 3 power 2 and x power 2. And then this is going to be divided by the negative half power, again is going to be applied to the terms inside this bracket. But instead of applying the negative half in, I'm just going to apply the power half into all the terms first. So this is going to become 81 power half. So square root 81 is 9. Y power 6 to the power half. So basically the powers get multiplied. And z power 0 is just 1. So that's not even going to appear here. Okay, so this is what the expression looks like as of now. And then here there's a power negative 1. Okay, now I'm going to rewrite this expression because power negative 1 means this expression is going to be in the denominator. The power negative 1 is for this whole bracket. So that's why the whole bracket is now in the denominator. And then lastly, divide. I'm going to change this to a times so that I can flip this fraction to 9y cubed over 1. And then from here, we can simplify to get our answer. Okay, so a very simple recap of how the laws can be applied and how we can simplify this expression. So this is all still more of a E-math type of question. You will get this kind of questions in E-math. Let us look at example 2, where something is slightly different. Okay, so if you realize, right, one of the key differences for example 2 is, of course, it's a fraction. That just means it's a bit more complicated. But the other key difference is that there's a plus here. And pay attention to this because remember just now I highlighted that the two sets of rules I grouped together, right, can only be applied when there's a product or a division. If it's product or divide, then we can actually combine the terms together. You either add the powers or subtract the power. There are some ways that you can combine the two things together. However, there was no rule for when it's a plus or minus. So technically speaking, there is no way you can combine these two expressions, even if you write it in terms of the same base. Okay, so I want you to keep that in mind. So keeping that in mind, right, one of the strategies is for us to do factorization. Now, why do we do factorization? Because do you realize that when we factorize something, we are basically writing it as a product. After we write it as a product, then there could be ways for us to simplify this expression. Now, in order to write it as a product or to factorize it, we need to identify what is common. So in the two things I have underlined, right, you need to figure out what is a common factor. Now, if I leave it as 16 power x plus 1, I may not be able to see what's the common factor. So it will be useful for us to rewrite the expression with a common base. So here, the numbers that I see, generally 16 and the 8, all of these numbers can be expressed with base 2. So I'm going to write the 16 as base 2. And the 8 can be written as 2 cubed. So again, base 2. Okay, now, right, if you are aware, you would see that actually there's a 2 power 4x here and there's a 2 power 4x here. Can you see that something common is starting to appear? Which means we can factorize 2 power 4x. But maybe before we factorize out, because I also know that this 2 power 4 will also be multiplied to this power 1 here. So it's actually going to become 2 power 4x plus 4. So if I were to factorize the 2 power 4x, you need to think of what will be left from this term. Let's take a look at that in the next step. Before that, for my denominator, I'm just going to rewrite this so that I can simplify it in my next step. Okay, so this term, right, if I take out 2 power 4x, what's going to be left is going to be a 2 power 4. I'm basically splitting the power. So 2 power 4x plus 4 is the same as 2 power 4x times 2 power 4. So that's why when I factorize out this would be left inside the bracket. Then here, when I factorize out the 2 power 4x, I'll be left with a 20. So I leave that inside the bracket. Now for my denominator, I managed to write both with the same base, which means I can add the powers together. So it's going to become 4x plus 3. Okay, so the denominator also happens to have a 2 power 4x, which means I can rewrite this as 2 power 4x. Can you see that the numerator and denominator now has the exact same term, 2 power 4x? So that means it's a common factor, which we can then simplify to become just 36 over 8. Okay, so this is how we can simplify this expression. When we started off, the problem with this question was that this was a plus. So we saw how we overcame that in this question by factorizing the common term. Now let us look at practice 1 on page 3. Practice 1 is quite similar to the question that we did earlier. So you may want to pause the video here, give yourself a couple of minutes to try this question before you take a look at the answer. Okay, for this question, the numerator, there is a product, so that's good. 32 can be expressed as 2 power 5, so that's also good, I guess. But the denominator has a minus. So that's not good because that means the denominator, the two terms, can never be combined together. So that's when we look for, is there anything common that we can factorize? And I think this one quite clearly, you can see that there's a 2 power n here and here. So it's a matter of how we're going to factorize that out. So if I factorize the 2 power n, what's left from here? 2 power n, if I divide 2 power n, what's left is just a 1. not a 0 but a 1. We remember we are dividing the 2 power n out. Then here, if I take out the 2 power n, what's left is 2 power negative 1. Again, if you are not able to see that immediately, basically I'm writing it as 2 power n times 2 power negative 1. So if I factorize this out, what I'll have left is 2 power negative 1. Okay, then my numerator, I can simplify it. However, I'm actually going to leave it like this because the denominator has a 2 power n. I also notice the numerator has a 2 power n. So most likely these two can cancel. So rather than to express the 32 as 2 power 5 and combine everything together, right? I'm going to leave the 2 power n on its own. Can you see that from here, this expression will simplify 32 times 2 power negative 2 is basically 1 over 2 square. So I can simplify this. Now my denominator will just have 1 minus half. And from here we can simplify the numerator to 16.